And I'll give the word to our moderator, Professor Leila Bettina, that we are very happy to have you here, Leila Bettina. Please, the floor is yours.
Thanks, Francisco. So I'm glad to be here, at least remotely. I find this quite a challenge, but let's see how it goes. And I got sort of promise from Francisco that he will be my backup in case, the connection is not so smooth and it's not so easy to do it at distance. But yeah, let's try to do the best we can. I understand we have two panelists also remotely, Meltem and Or. But that's also, although all of you were participating already today before, I think it's nice maybe for people that maybe just joined now to have a quick round. So there are again 4 panelists in this last table, which is called Lessons Learned, which means we'll try to follow up on the most important things that were mentioned today, and maybe a bit of forward-looking with respect to agility, standardizations, and all these issues that were discussed today. So I'd like to ask each of you to say a few words just to introduce yourself, and then we take it from there. So we have first Brian Lamacchia. Brian is there, I see.
Yep. Hi, Leila. Hi, everyone again. Brian Lamacchia from Microsoft Research and the security and cryptography team there. That does some of the post-quantum submissions. I'll leave it at that.
Okay. Hello, everyone. I'm Rafael. So I'm working with Google on the PQC transition, and I'm also working on a couple of submissions now considered by NIST in the 4th round. And I also maintain, I'm one of the maintainers of the TINC, which is the Google Cryptographic Library. And that's it. Yeah.
Okay, thanks. Meltem?
Hello, my name is Meltem Sarnasturan. I have been working at NIST for the last 13 years and co-leading the NIST lightweight crypto standardization process, and also involved with other symmetric key related standards.
Thanks, Malcolm. And Or, again.
Well, I'm a professor of computer science at the University of Haifa in Israel. I'm not working neither for industry nor for government, so I guess I'm also representing academia here. So tough luck for me.
Okay, thanks. Thanks all for introducing yourself. So yeah, let's start a bit more general and in the spirit of the main theme today. So the first question would be, so based on what we heard today and what we kind of learned so far, how would you address the problem of crypto agility, assuming that there is a problem? So where should we take it from? Anyone?
Maybe I can start. So, so in my perspective, we are writing the NIST standards, right? Even crypto agility is also a problem in standardization part as well. Not just, we have algorithms implemented in the field, but also it's a problem for standardization. So how quick can NIST respond to attacks? So we see that it's very challenging, and it takes a lot of time for NIST to respond, even to, getting rid of SHA-1 right now. We're still working on, because of the push from the industry, we have all these implementations. What happens if if the application only uses pre-image resistance of SHA-1, not collision resistance? So there is a push from the industry. So it's also challenging to update the standards when there is an attack. So, and also I want to mention that due to this, like last year, NIST formed this crypto review publication review board, so that we can actually periodically go over all of our standards and make sure that we are up to date with all the updates in the crypto research. So just wanted to highlight, this is a challenge even in the standardization process as well, not just everything in the field. What happens to the algorithm to the field?
Thanks, Meltem. Someone wants to add something to this?
Maybe I can just add that from a system perspective, I think we need to think about crypto agility since the early design of our systems. This is not something that we've been doing in the past. And I think, for example, building a system with just an abstract description of what kind of cryptographic feature we expect and develop the software in a way that any implementation that meets those requirements would be suitable for that implementation. So I think that's kind of a different paradigm on how we develop software. And I think that's very much needed.
Okay.
If I may add actually to what Rafael was just saying, think of the hardware. We also have hardware implementations running around, and you see it mostly in the lightweight crypto competition context. This was in the discussion in the last panel. Hardware to begin with is less agile than software unless you go to FPGAs, but then they carry with them some cost. And going back to the standardization of having a single option versus many options, you can look at ISO standards. ISO says, oh, you can use any of these block ciphers. Just pick any of those and they are going to be fine. And this causes quite a lot of havoc and problems, both for implementers and for other reasons. I mean, so having too many options is also not that of a good idea when you think of the ecosystem.
And I'll just add on to this, going back to the question of the standards work and say the fact that NIST has to update a bunch of their own standards once the post-quantum standards get done, things that depend upon it. That's true in a lot of other parts of the broad standards community as well. You know, we tend to think a lot about TLS as the prime example when we're thinking about a communications protocol and the negotiation that's already built into it. And we think that we've got a good handle on agility there. But there are a lot of protocols that we depend upon every day for internet communication that have absolutely no algorithmic agility in them right now. As an example, the last time I looked at DKIM, the one that is used to sign email headers between mail transport agents, specified the algorithms fixed and didn't have any ability to do any agility. They're going to have to do some updates. A lot of other standards will need to do updates. And that's why this cascade of dependencies among internet standards documents is going to keep us all employed for a very long time. And I'm glad that we're all going to have work to do for a while. And I'm only slightly facetious at that point.
Okay, so like it seems like all of you identify the issue, but how do we deal with it? What should be done?
Well, it's an architectural principle, right? And this is the sort of thing that we as practitioners in the field not only need to recognize and advocate for, but constantly make sure that the systems we build, the protocols we design, the systems we acquire and purchase meet our cryptographic agility needs, right? Mm-hmm. It is unfortunately the sort of thing that you have to constantly refresh in people's minds that this is an important security design principle, and that if systems are not designed with agility in mind, you're going to end up having to go back and fix them later. And there is tension, like you heard earlier today, between that and other features, but this is the sort of thing that you can't be lax about. And it's an ongoing, software and hardware development issue.
Mm-hmm. And is there something that ongoing competitions could take as a message, like how to address this issue while running competition at the same time?
Well, I don't think the fact that we're running a competition stops the need for agility and design. I mean, as Raphael said, I mean, you can specify the requirements of it, and you can test with things that are out there. I mean, I think this is one of the best things about the Open Quantum Safe projects from the beginning, was that it put a cryptographically agile library out there that allowed people to go test all of the PQC candidates at a particular stage, or almost all of them, relatively easily, and you can see what the impact is. And in fact, that's advice I've been giving customers for a few years now. When someone would come in from a particular vertical industry that said, well, what are we going to have to do? I said, well, why don't you go try things out, especially in your proprietary implementations of protocols that are totally within your environment. Start doing the work now, even if you're testing against an algorithm that isn't what NIST chose as the winner or one of a winner. The fact that you do it and that you have tested to see that, you know, your protocol works with something like Frodo is going to prove that you can handle large key sizes and larger signatures, or, you know, encryption sizes and things like that. That will be relevant to whatever was eventually chosen. So the opportunity's been there, and the opportunity will continue to be there through round 4 and through the second call for signatures. And it's not a reason for the fact that competition is going on. Is not a reason to not do the work now, I guess the way I'll put it.
Yeah, it was just more of a question. Can we do it better knowing about all these issues, like already kind of plan for that, for easier kind of agility later on?
I think we've known of crypto agility since the 90s, right? And the early designs, if you look at the early designs of crypto agility, like IPsec or TLS, had their own notion of a sort of a crypto agility. Some of it worked better than others, and there is, you know, more agility in some of them and less in others. But we're almost 30 years later, and we still don't understand agility correctly, or to the point that we can say, oh, here is this abstraction level that just says, oh, we need a public key crypto system that is secure. We need a symmetric key crypto system which is secure, unless you open the theory papers where they do this abstraction level. But I'm not aware of any cryptographic library that says, oh, you just, you know, just plug in whatever you want. We would work that way. And one of the problems is because think of the implementation now, whether it's software or hardware, it's very hard to make good implementations. So by opening up the API to allow for any, you know, think of an OpenSSL implementation that you can pull whatever public key crypto system that you want in, and it will fix everything for you. Think it's going to be held to make it secure. So I'm not sure. Maybe Raphael can shed some more light how Google is doing that in their library, but something here is obviously not consistent with our other tasks of making everything secure.
Can you repeat your question? I'm not sure I understood actually.
So one way, the standard way in programming to have sort of an agility is to have some API, right? So the crypto library is going to have an API that says encrypt, and then you say, oh, I need the public key crypto system. Afterwards, I need a symmetric key crypto system, etc. So this API is going to be linked to some library that does public key and then symmetric key and then everything, and you just change things underneath. It's just that when you have multiple implementations, then suddenly you have issues with side channel attacks, you have timing attacks, microarchitectural attacks, I mean, that sort of stuff. So how the balance look from your perspective as the one handling the situation?
Yeah, no, I think your point, yeah, is very valid. Like we need to see how these various schemes would be implemented, how mature they are, how resistant to side channel attacks they are. I'm totally with you. But I think this doesn't contradict the fact that we need to have a generic framework so that if we have good options, we can easily switch. I think that's my main point. For example, I can give an example. We work on Tink, which is Google's cryptographic library. And in Tink, what we do is we don't have a key. We have a key set. So each key is in fact like a collection of keys. And the primitives are defined very abstractly so that you send a key set instead of a key. And if you rotate your key, for example, it will be a transparent process. You have a given key, for example, that you are using until now, and in the future you switch to another key. this key will be still part of the same abstract concept of a key set. So this is kind of one technique to make, for example, key rotation easier, and eventually maybe also allow multiple crypto algorithms performing the same primitive. This could be one way of respecting the API, as you said, but still having some degree of flexibility in terms of crypto implementations.
That
Not sure if I answer your question.
Yes, but doesn't this imply that cold boot attacks become easier and things like Rowhammer? Because if you keep on holding a key for the key rotation, suddenly its validity period, or the period it exists somewhere, is longer. So
can you repeat that? I'm not sure if I can.
So my question is, if you hold onto the key after it is valid for a longer period of time because of key rotation issues, doesn't this imply that cold boot attacks or other side channel attacks that look at the memory in some sort of manner are more likely to happen?
If I understand your question, it's about like having keys for a long period of time since you rotated, and whether this will open for more side channel possibilities, right? Yes, that's totally right. And this connects with another very important problem in real world crypto deployments, which is key revocation, which is very hard to do it in practice. So my answer is in the best scenario would have like a key rotation policy, which may even change the crypto algorithm together with a key revocation mechanism that works great. So I think that's what we need. Now in practice, I can say that revoking keys is a very hard task. It's a very hard thing to do in practice.
Okay, does that answer your question, or?
Yes. If I understood Raphael's correctly, the answer is it's complicated.
Yeah.
Right?
Thanks. Exactly.
Okay, I guess we all agree with that. Yes, so we should kind of try to follow up on the most interesting points from all tables. So maybe move a bit from agility to post-quantum. And the question I would like to ask, maybe all of you, is if you see so far the NIST post-quantum standardization process a success, and what did we learn from that so far? Anyone?
Want to go first?
Maybe I can just emphasize once more about the need of hybrid, and not only the need for deploying hybrid schemes, but also highlighting the complexities of deploying hybrid schemes. I think we mentioned briefly in the previous panel that CAMs, I think it's kind of very easy to do the hybrid. You just perform the 2 CAM and then you just apply a KDF on the 2 secrets. But the thing for digital signatures is something that I really want to highlight, that this would be probably a mess because we have so many options. We have the 2 parallel certificates, for example, or 1 signature over the other. I think what I want to share here as a lesson learned is that this problem looks like a very complex problem in practice. And I think the community needs to work together to hopefully quickly converge to a single solution.
Someone wants to follow up on that?
So I'll completely support everything that Raphael just said. Leila, I think your question was, has the process been a success so far?
Yes.
And yes, I think it's been an absolutely unqualified success. Look at the research that has been stimulated by the NIST post-quantum process alone, right? 70 plus submissions from around the world. The first major, sort of international competition in this field. We got a whole bunch of good candidates. A whole bunch of PhDs got written on and research out of it. And we're now down to, a set of winners and a set of finalists. And we are still stimulating absolutely spectacular research results that surprise us even within the last few weeks, right? So how can you say, of course it was a success, and I'm thankful that that the US government basically allocated funding for NIST to carry this out like they did for SHA-3 and like they did for AES, because this is a standard that we're going to be working with for a while. And I think the community participation in this has been a great thing, and that it's all being done out in the open with everybody to comment on. And now the next stage of that work is now going to come on, even as this finishes round 4, and we've got to put the same amount of effort into that. But yeah, I think it's been an unqualified success.
So there is nothing that could be done better, you are saying?
Well, I wish Psych was doing better, but I mean, I'm not gonna, look, I think you always have trade-offs when you are trying to guess on rules. NIST has to lay down a set of rules early on, and you're trying to predict a certain sort of thing. And there were comments on choices that were made early on in the competition. I think they're basically ran, as best they could, meeting the requirements of the charter they were given. I'm not sure what more you would actually look for. Do you have some ideas in mind?
I as someone who doesn't really understand post-quantum cryptography, especially the public key parts, I think that we see in the last few rounds, actually the last few weeks, things which are not actually a huge success. I mean, besides the Freedom of Information Act complaints running around, we see an issue with patents, something that in other competitions we haven't seen. And I think that to one extent, I completely agree that with what Brian said, in the sense that it inspired new research, really amazing research. There was a huge effort by everyone, both from industry and academia. There was a lot of involvement by all the players around the table. And we see now people working on some of the mathematical assumptions. And I think this, there is a good chance we're going to see again the Braids Group's massacre of 2002 or 3 or 4. I forgot when the real massacre happened, but there was a series of, if you remember what happened with Braids Groups. But on the other hand, and I think this is something that the competition or NIST had to handle in a very in a slightly different way. I'm not sure I have a solution for that, is the IP issues. And I think this is going to impact the outcome, and especially the adoption of the lightweight crypto competition, post-quantum crypto competition winner.
Any comments on that? I mean, I would also like to encourage the audience. I don't see the audience there, obviously, but we have some people in Zoom. That's what I see, and I assume some in the room there as well. So it would be nice to get some comments.
Yeah, while someone's going up, let me just respond. I'm not going to put NIST on the spot here, okay, but I'll respond to Or. Certainly, IPR issues are of significant concern to anybody in industry, and we saw the adoption of ECC was delayed significantly because of IPR concerns. Whether they were justified or not is neither here nor there. I will point out, and I guess there are some choices NIST could have made a little bit differently when they set the process up. The IPR rules could have been a little bit tighter. Some of these were suggested in the public comments from that I wrote for Microsoft and for others. That'd be more like what happened when they did SHA-3. We live in a different world now, and that's not what happened. That being said, in our world as it lives today, we cannot fully eliminate potential third-party IPR claims, and that's something that we all just live with in industry. No matter what you do, you can't guarantee anything, because you don't have any relationship with people who aren't party to the competition. And that's just a sad fact of life. And it's one that we live with, and we've seen it come up time and again in industry. But maybe we could do more the next time NIST chooses to go run a competition, if they ever decide to do another competition.
I want to remind everyone during the AS competition, there was some patent claims by, if I remember correctly, it was a Korean company that claimed that they had patented fixed bit rotations in cryptography. Now, the patent was, some of you may think of this statement as weird, especially given the fact that any block ciphers that we know since, I don't know, 80 something are using fixed bit rotations. But the patent, when the community went against this patent, at some point I remember Nessie, the European project Nessie, saying something, issuing a statement saying this patent is bogus now. And I think that in this case, the patent was not from some third party, completely uninvolved and outside our community, right? Someone very close. And I think that with third party, with very distant patents, yes, of course, we can't handle it, right? If somebody comes up 2 years from now and say, here, I have a patent for the white trail strategy, and it was issued in 98 or 96 or 95, it's going to be very hard to counter that. But this patent was on the table from day one. So I'm not sure that I'm worried about the third party liability. I'm more worried about people around us liability.
Leila, we have a question here.
Yes.
Me?
Go on.
I was just wondering what we could have done different with respect to those 2 patents that we have to handle. I just don't know what we could have done. The question made, right?
I will point you to the comments that I wrote and filed in 2016 to the, okay, I mean, you've asked, right? So, you know, when the draft rules came out and went out for comment, the IPR rules were in there. They were both royalty free as well as RAND. NIST could have considered a stronger requirement on participants. Okay, and we can debate the pros and cons of this. But for example, NIST could have said it's got to be royalty free. NIST could have also said that if you choose to participate in the competition and you have any IP that reads on the eventual winner, not just your own, that you allow that to be used for free as part of implementing the standard. That is, that there would be a cost to entry. Now, you have to weigh the benefit to the community of trying to diffuse some of those claims to the, does that cause some people to not participate? And you want everybody to participate. So I'm not saying that that's necessarily guaranteed to be the right thing, but there are trade-offs in this, right? You know, the fact is we all had to sign certain declarations. And the question is, could you have done more? You know, could you require, you know, some preordained grant independent? I don't know. And I am not an attorney. So, you know, I don't even play one on the internet. So, but that would be the sort of thing to think about. And, you know, whether or not the lawyers at various places would allow something like that.
Can you repeat the question, please?
So I think Renee's question is not the original SIM, but is there anything that could have been done sort of while the competition was going on to do that? And frankly, I am hesitant to step into the middle of NIST's ongoing negotiations or whatever is happening. I am cognizant of the footnote in the round 3 report that says there are things ongoing. I don't want to disrupt those. Well, I'm not sure how I could disrupt them, but the point is, you know, let's see how things come out, right? I I don't have a good solution for that. And I don't even know if there was a solution that would work for the United States would work for the rest of the world, because we want this to be a worldwide standard. And IPR rights are something that are country by country basis. So I don't know, right? I mean, if the US government had an infinite supply of money to throw around to buy out patents proactively in cryptography, that might help fund more crypto industries, but you know, that's not the world we live in. So I don't have an answer for you. I think as best we can tell from the outside, I think you all tried to do what you could when you could, but again, we're not privy to that process, nor should we be.
We have a comment, Leila, from Joan.
Yes,
Question?
I was gonna close on this post-quantum and then maybe move to the lightweight standardization. So that relates to lightweight more, I think. No, also, yeah, sorry, post-quantum actually. So maybe Meltem, can you read it?
Sure.
I think, yes, maybe something you comment on.
Yeah, Johan's question is, many post-quantum make use of one of the shakes. So I think this is to generate some randomness. Shake.
We cannot hear you.
You don't hear me?
Yeah, but it's not the question.
I assume you hear me, and
Now we can hear you. Yeah.
okay. So shake is the sponge construction based on the Ketchuk permutation that has originally 24 rounds. And FIPS 202 defines Ketchuk permutation with other number of rounds.
We cannot hear you again.
I don't know what is.
Now we can.
Okay. Yeah, the question is about approving shake, which is based on Ketchuk permutation with smaller number of rounds. And I think Johan is proposing NIST to approve this as a new hash function or a pseudo-random function. I'm not sure what the exact question is. But yes, I think post-quantum algorithms make use of shake to generate randomness, but Johan is here, maybe he also wants to clarify.
Yes, so the point is that in many post-quantum schemes, shake is one of the slowest components, but it has twice the number of rounds that it should have. So if you look at AES, there are attacks on AES for 6-7 rounds. For shake, there are attacks for up to 6 to 9 rounds. So this 24 rounds is a huge overshoot. So why isn't there a discussion to reduce the number of rounds, or at least could think about it? And there's completely silence about that.
Did you follow, Melton? Yeah.
I mean, shake is already part of the standard, right? So it's whether NIST, is it a good idea for NIST to have another variant with smaller number of rounds, especially among all these trust issues? I don't know. I don't know how it would be, how would the academic community, other communities would respond to that? But technically, I think I would also be very comfortable with 12 rounds for shake as well. But at this point, it's not my call to make or approve any algorithms.
If I may suggest that reducing only one of the standards to 12 is going to be kind of weird, and then you're going to have, if you're going to use shake in anything which is not post-quantum, you should use 24 rounds. If you're using shake for something which is post-quantum, you should use 12 rounds. And if you're going to do implementations in libraries, you're going to have to implement it correctly to support both 12 rounds and 24 rounds. And now the complexity of implementation has grown a bit. If you're doing hardware, that's going to be a complete mess. If you're going to do software, you're going to have various issues. that follow, I'm not sure that we tested or checked how such primitives handle the fact that the number of rounds change. I mean, you may get into slide attacks or some suddenly
no, we took it into account when designing with the round constants. So
no, in the sense that suddenly, okay, sorry, not necessarily just slide attacks, but suddenly you have related schemes attacks. So think, for example, of a cipher that can be producing output after, think of even AES. The same key and everything, you can produce AS128 with 10 rounds or 11 rounds. And suddenly supporting both of these operations, I can assure that there's going to be at least one implementation that would allow you to see the encryption after 10 rounds and the encryption after 11 rounds under the same key. And then suddenly, if you look at the difference between the two ciphertexts, there is only 1 round difference. So I'm not sure that this sort of analysis has been done, even though you say, oh, the distance is still going to be 12 rounds. I would be very cautious of.
we looked at it.
And besides you, Jan, are there other groups or people who worked on this problem? So my point is holding both two different types of standards using the same primitive is going to cause headache, both from implementation-wise and security-wise. If you answer, you have worked on that and you're assured, that's great. We would like to see other groups validating this claim. But there is a problem here that personally I would, and I think this is something that came out actually from the post-quantum crypto. Suddenly somebody introduces a new assumption and then, oh, it looks reasonable. And then suddenly just a few days after the competition ends, there's a problem with the hardness assumption. So I would be very cautious. And I think that if this did something which was very good during the post-quantum crypto is like being very conservative with the hardness assumption. We want our standards to be, in that aspect, conservative.
You have a question? Just Mike. Leila, there is a question here.
Instead of me just yelling so loud that like Johan and Or can hear me. Okay. One thing I was going to point out, when I think Johan made a comment about, well, there's just been silence from NIST about reducing Shake to 12 rounds. There's a real bandwidth problem here as far as how much stuff we can work on at once. So a proposal to redefine Shake to a smaller number of rounds isn't something we would do just by saying, oh, okay, well, Johan says it's okay, let's do it. It would be something we would have to go through and spend a fair bit of time making sure was okay and doing some of the stuff Or is talking about looking around for analysis. So it wouldn't be something trivial. And I say this as somebody with absolutely no power, right? Like I can't make anything happen at NIST. I'm just a cryptographer, but I can tell you it's not so easy for us to just jump into yet another project where we're doing a major thing. And if we were going to do that, that would have to be a separate project we would do that would take some time. So it wouldn't just be a quick, okay, well, let's just flip it to 12 rounds. The other thing that Or said about having the problem of the two different versions that were very similar, I think you could resolve that. If I'm remembering right, Johan is here so he can say something. But there are domain separation bits in the padding. I think you can use that to get distinct instances. So I think that would actually resolve that problem. So you wouldn't be getting exactly the state after 6 rounds and then the state after 12 rounds and then also the state after 24 rounds and be able to do some weirdness between those two. So that's just my quick comment.
But it's of course it's not this domain separation is for different capacity values. It's not for different number of rounds. We try to address the different number of rounds with the round constants. But I agree that having multiple versions in parallel with the same keys, that's a danger. But a priori, Shake is used without a key. Huh? So there's no, how could I say, there's no infection of one to the other. As soon as you start using this different functions with different number of rounds with the same key, then you're really, then you have a risk. although I think it's mitigated, but I would never recommend doing that. So if you use different algorithms with the same key, that's really a no-go. At least I think it would be good to have at least a discussion about it, but there's complete silence about it, and that's what I don't like.
Just to clarify, Johan, you say FIPS 202 defines catch-up with other number of rounds. So this is the number of rounds is determined by the size of the permutation, right? It's not arbitrarily number of rounds. It's just
So in the standard, the catch-up permutations are defined for any number of rounds, but it's not endorsed. So you have all these different size versions, catch-up F 25 up to 1600, but only catch-up F 1600 with 24 rounds is endorsed in the standard. But all the other catch-up F versions are defined. And the catch-up F versions with a different number of rounds, we call them catch-up P. And the number of rounds is a parameter.
correct, but they are not approved for any use in any.
The only one that is approved is actually catch-up F 1600. Yeah.
Leila? Yeah, go ahead. No.
Leila,
your
you're-
phone, your microphone.
Yeah, sorry. I'm back. I muted myself. So maybe we can move on. I think this is and conclude this. This has been quite discussed, this point. So maybe we wanna also discuss a bit on lessons learned from the lightweight standardization. Again, maybe pointing at Meltem with the standardization lessons learned issue. So maybe a question for me, and then also the same question for our panelists, like, do you think it was a success overall? And my question to Meltem is, I think you said in the previous table that you NIST aiming at one finalist, one standard, and then speaking of one lightweight standard. And also some of issues were brought up, like with respect to which property you see it as lightweight, in which use case. Does it mean that you have like one definition for lightweight? And if so, which would that be? So like in which specific use case you would then go for lightweight in that sense?
Yeah, so it is. Well, there's no one definition for lightweight, right? So we have hardware applications, we have software applications, and we have different metrics. For each of these applications, we could look at area or power consumption, latency, or code size. And we, based on the benchmark results, we are also benchmarking the finalists and also the AES, GCM, and also SHA-2 in these comparisons. So then we want to see where AES is. So if the algorithms do not bring significant performance advantage over AES, then there's no point, like at least 50% or 100% improvement we are expecting. And we see that AES is doing well in microcontrollers and software application part, which is kind of what we expected in the beginning. And we see that there is improvement in the hardware in terms of area, latency in the hardware applications. So we are going to focus more on the parts where AES is not performing well. But we are also expecting some results for the protected implementations, which we don't have yet. And once we have those results as well, we will see which algorithm provides more benefit compared to AES.
Yes, but since you mentioned several things, there will not be one single candidate that meets all those requirements. So it will be a sort of, a bit of like, trade-offs, like that much better when protected, that much versus not so great in hardware. So it's not going to be an easy decision, I assume, right?
That is correct. It's not going to be a trivial decision. But at the same time, we are aware that maintaining standards are hard and different. So that's why we want to have a simplest solution that might cover most of the area, that might answer most of the needs from the industry, hopefully.
Okay, I see.
We have a question here in the audience, Leila.
Yes, great.
Okay.
This question is mostly related to the agility. The NIST finalists, we have like a lot of primitives and there is varieties. We see stream cipher based algorithm. Also, there is I think there is 1 to 12 block cipher and we have permutation based. So in terms of agility, which one of them do you think is better in terms of cost?
So none of them will be a drop-in replacement for AES. So I actually don't know which algorithms would be harder to switch in terms of underlying primitives. But maybe, thinking about, for example, grain is the only stream cipher in the finalists, and it kind of fits. It is harder to make it fit to the API that we currently have. There are some challenges. Maybe going with the stream cipher design would be more challenging, but in terms of agility, I honestly don't know. Or you have a better answer.
I think, if you think about the sponge function, then you just abstract away the permutation may offer nicer agility to some extent. The same goes with a block cipher. You can just plug in another block cipher because the mods around, and I think this is something that NIST done here, the lightweight crypto competition, unlike the AES competition. There was one competition for a block cipher and then a different competition that I think nobody remembers anymore about the mods of operation. They're completely separated. Here in the lightweight crypto competition, they're actually tied together. You have to specify the full AEAD scheme. In that aspect, I think that the agility is going to be very difficult to switch from one mode to another. So if you picked permutation based or a block cipher based or a stream cipher based, it's going to be very hard to switch to something else. Of course, in software, maybe Raphael knows better. I think in hardware, it's going to be a complete hell to handle that, especially as the API, the interfaces of what's going in, what's going out is going to be completely different. So I'm not sure it's going to be good, but again, maybe Raphael, from software point of view and APIs, you know better. So.
Yeah, I think my answer is that it's very complex as my previous answer. So
something related to the similar question to NIST PQC algorithms. So we also have diversity there, code-based and lattice-based. So a similar question.
I'm sorry, can you repeat that again?
I mean, like in terms of agility, which you consider as like good in terms of cost?
In terms of cost? Well, look, are you trying to ask which one might be easier or more difficult to support agility in? Okay, so then what you really got to look at are the parameter sizes for the algorithms you're looking at. And, let's take, so this comes back to designing an API that basically can take different size public keys, private keys, ciphertext, signatures, things like that. I think where I worry most right now from an agility perspective is not about any of the individual particular candidates, but the general fact that all of the post-quantum algorithms that we're looking at exceed the sizes of RSA and ECC in at least one dimension, where you look at the dimension of public key or ciphertext or signature. So the things I worry about are where in a code base that maybe was designed 15 years and written 15 years ago, when that was all we cared about, that we might have implicit limits in the code base that we're going to run into when we try to migrate. This is one of the reasons I've been pushing teams internally to start testing with much larger certificates, because I don't want to run into a part in the code base where, you know, well, nobody's ever going to need more than 16 kilobits to hold a key, because that's the largest RSA key that we even support in the API. So let's just put a hard-coded limit in that that's the key size. And all of a sudden, we're now talking about much larger public keys than 16 kilobits. So I was heartened by the fact that we were actually able to run in the example where we used round one picnic signatures and certificates, and we could run 33 kilobyte signatures on X509 certificates through the OpenSSL stacks that we modified. So that's a real concern, and that's an engineering concern. And it's not malicious. It's just that there were engineering assumptions that were made when some of these, even our best attempts at making cryptographically agile APIs. I mean, if you look at Windows, our first cryptographically agile API was Crypto API 1.0, and that shipped in the mid-90s. And it was agile. It was agile for RSA, and it was agile for DSA, and it was agile for Diffie-Hellman, because the use cases for agility were hardware implementations of those as opposed to the Microsoft software ones. ECC required we put a whole new API in. That's why you have CNG. I don't think we have to do a new one for post-quantum, but I worry about other parts of the software stack where there are the implicit limits in. And I think everybody should kind of go look at that. So that's the cost I care about, okay?
But wouldn't some of these problems also be existing in a protocol level, right? If you suddenly cross the size of the TCP packet window, like 64K,
yep,
you're going to get into trouble from the network layer, not even before it reaches your computer. So have we contacted the TCP IETF task force to tell them, hey, you need to update TCP to support post-quantum crypto?
I believe that's part of the reason why Falcon was considered a signature, a candidate, right? Was exactly some of the, I guess, the individual packet size lengths. And yes, or I suspect we're going to find all sorts of interesting problems in some of those protocols as we do test deployments. And we will continue to live in interesting times, is what I suspect is going to happen.
Okay, thanks. Francisco, any more questions from the audience?
Not right now.
No, but it's also maybe almost closing time.
Yes.
Maybe a good point to ask a question to this table also about the kind of your overall opinion on this initiative to organize a workshop like this. So do you see this GHTC becoming a serious? And the question is more like, are we going to need another one of these workshops in a year or so, or what do you think? Are all our problems with agility be solved by then?
So I think you're going to need one in a year. And what I hope it is that we actually see some research papers on cryptographic agility. I think it was Kenny Patterson and David Ott at VMware had the paper on where's the research on crypto agility. And that's a really fair question, because like, this is clearly a hard problem that has been, that has bedeviled us for decades. And yet I don't know of a lot of actual research on how to design cryptographically agile systems and make sure that agility is respected as part of the software development process. And I think that's a great research question, and we're going to need more of it as we're also in the middle of rolling out more agile systems. So I think there's some good systems research to be done there. And maybe that could be the focus of a future workshop. That would be my thought.
Yeah, I'll just add that actually crypto agile is a topic that it's a topic by itself. it really deserves, for example, its own crypto conference, its own workshop. So I think there's a lot of work to be done there in kind of, for example, systematizing what we need from a crypto agile perspective, creating generic frameworks. I think it's really a topic by itself. It's not only like something we apply here or there. It's a whole new science, if we can say.
I want to echo the two previous panelists, and I would suggest, just to start with, we don't know how to do standards correctly in cryptography, let alone doing standards that support crypto agility. And there's a conference which is dedicated for standards, SSR, standardization something in something. It has been running for a while. We still haven't solved all the problems of standardization. I guess that crypto agility is the next target for a new series of conferences and actual seminars and meetings. So Francisco, you're invited to start an actual seminar on that. I'm sure that some people are going to be interested in going there for that. And I would be very happy to see it next time, you know, either at Eurocrypt, actually, if it's something which is global, maybe not attaching it to crypto, but switching between conferences would be a nice idea.
Nice.
We got a question here in the audience.
Yeah, I was just gonna ask, just to point out, when we talk about agility, we actually mean a whole bunch of different things, right? One meaning is when something's broken, I can turn it off and TLS still gives me the little lock icon. And at a completely different level, it's stuff like, well, when we roll out a whole new crypto system, we don't have to rebuild the whole code base, or we don't have to read it. And that winds up touching not just whatever crypto code there is, but all the networking stuff and the bigger protocol design. It's a big problem. And part of it is even defining where you're gonna kind of what you mean by crypto agility. And I feel like that's a place that is maybe a good place to start when you're thinking about doing this work.
And John, I'll just add to that, there's a really big policy issue in terms of configuration policy, right? Because I think those of us who tend to write cryptographic libraries focus on the agility at the core API layer. But if you are administering an enterprise and you are like, oh my God, I just saw this paper that tells me I can't use this algorithm anymore. And you're trying to reconfigure your cryptography policy across your enterprise. That is not an easy thing to do right now to even turn it off. The turn it off may require that you understand 17 million different config settings all over the place. And, you know, that percolation from the top level enterprise policy down to the low level API, that's not there. That's right. So you're right. There's a lot of pieces to this.
Okay, thanks. I guess it's time to wrap up, Francisco.
Yeah, may I ask just one remark about lessons learned? During the morning, we were saying in the two first rounds that it's always dangerous to make predictions, especially about the future. But can we say that the future is post-quantum? Is irreversible? Are we?
Oh yeah.
Is
like I don't think there's a question about that.
okay? So it's a prediction.
Yeah, it will be post-quantum. Like I said earlier, I believe it will be hybrid for at least the rest of the decade. I will not make predictions about when you will routinely be able to make a TLS 1.3 connection using a hybrid classical plus PQ scheme across the internet. But I think that's the first major implementation. But we're going to see rollouts over the rest of the decade, right, as things go. And, you know, hopefully we've got enough lead time on when that cryptographically relevant quantum computer ever shows up that we're going to be okay. And I think we do. But
okay.
Yeah.
Okay, thank you. Okay, so maybe it's time to close this first edition of the GHTC workshop. We would like to thank all of our distinguished panelists and moderators. And on behalf of the organizers, we thank you for being here, and we look forward to be again in 2023 for the second edition. Thank you. Special thanks to all that didn't go to bed as I recommended.
He changed his background though.
Yeah, it's 1:30 here. So
Well, yeah. Well, best regards. Take care.
Bye.
bye-bye.